Okay, we'll start. Welcome once again for the next session. So I'll be the moderator for the session titled How Descriptors Work, presented by our speaker, Rodrigo Girão Serrão. Here's the brief overview of the session. As we all know, descriptors can be confusing for many, but Rodrigo will demystify them in his talk. He will provide an example that demonstrates how descriptors work and explain why they are useful. By the end of this session, you will be able to implement descriptors in your code and understand these practical applications. And to give you a short introduction about our speaker today, Rodrigo is a problem solver and a programming enthusiast. He shares his knowledge through his blog, workshops, and courses. Rodrigo's areas of interest include mathematics, numerical analysis, Python, and APL programming languages. Please note that this talk assumes some familiarity with properties and their implementation using property decorator. It is designed as a refresher for those who already know how to implement and use properties. And feel free to ask questions during and after the talk, and Rodrigo will be happy to provide clarifications and insights. Now let's give a warm virtual welcome to our speaker today, Rodrigo, for his session and how descriptors work. The stage is yours, Rodrigo. Yeah. Can go ahead.
Thank you Thank you very much. Good morning, good afternoon, good evening, depending on where you are right now listening to this. It's a pleasure to be here with you today. Let me just move your faces over there. All right. So I hope you can see my slides. It's a pleasure to be here presenting at PyCon Sri Lanka 2023. My talk is indeed about how descriptors work, but I like terrible puns, so I wrote here describing descriptors. And I was already presented or introduced. My name is Rodrigo. You can find me on Twitter, where I share some Python knowledge. And just to give you a very, very short taste of what I do day to day, I work for Textualize, where I write Python code. And it was actually on the job, so it was working for Textualize that I realized how descriptors really worked, and that was what prompted me to create this talk. And then I also write about Python at mathspp.com. So that's my website where I write blog articles and some self-published books. Now, the slides for the talk will be available on GitHub. Actually, they already are. I'll be probably updating them if I find typos during the presentation. And I just fixed something, so it isn't 100% up to date, but you will be able to find the talk slides there. So now, without further ado, let's jump straight into the talk. Let's talk a little bit about attributes. And actually, before we start talking about attributes, feel free to use the Q&A. If you have any questions, feel free to type them. I will try to keep an eye out for questions as they come in, because they might be relevant while I'm talking about something. Otherwise, by the end of the session, we'll just go over any questions you might have. But so let's talk about attributes. I defined over here a small class to represent a person. And the person, as you can see, will have a first and last names, and I will save them in their respective attributes. And then I will create an attribute name that's going to concatenate the first and the last names. So then if I were to take a look at how name looks, or not how name looks, but the way it's computed, the thing that I really want you to focus on right now is that we have two parameters, but we are creating three attributes on the instance. So the first and the last come from the parameters, but then we use both of those attributes to build a third one, right? And now the reason I want you to focus on this is so that you can take a look at what happens if we were to use this class. So right here, I'm creating a person called John Doe. And when I print John's name, I get the string John Doe back. Fine. Now, what's interesting and slightly undesirable is what happens if I change John's last name to Smith, right? Because if I change John's last name, John's name now should be John Smith, but actually the print of John name is still John Doe. And why is that? The reason that happens is the name here on the left, it has dependencies, right? It depends on first and last, but we only computed it once. We computed it when we created the person. And so when we later updated the last name, John.name became outdated. And that's not good. Sorry, I skipped the slide. So now we want to fix that with dynamic attribute computation. And these three words, they might sound confusing, but it really is not. Notice that's attributes we're talking about, and we want to be able to compute them dynamically so that they reflect the changes that happen in our objects. So how can we do that? This is the class we have, and we're going to use properties, or we can use a property to do this. So the first thing we do is we create a method that has name. The method name is name. So we preserve the name. It was self.name, now it's def name. And we return the value we care about. And then we add the property decorator. So that's what we want to do right now. Now, if we are to create a person, John Doe, we can do the exact same thing. Now, when we try to print John.name, the interesting thing here that's happening is John.name over here on the right looks like an attribute, right? On the left, it looks like a method. But the nice thing is, because of the decorator property, accessing this attribute actually calls the method. And so this gets called and we return the name. And so we get John Doe. Now, if we change the last name to Smith, when we try to print John.name again, what happens is once more we call the method, and therefore, because we are calling the method again, we get an opportunity to recompute the name to its actual value, and so we get John Smith back. So the decorator property here was very crucial in allowing this to happen. And the main takeaway from this set of slides is that the decorator property kind of turns methods into attributes, loosely speaking. Right? And now what I want to do is, I want to show you our very first descriptor, and I want to show you how we can do a similar thing with descriptors. Because throughout the talk, I will be talking about properties a lot, and then I will be comparing them with descriptors because there are a lot of similarities, and that's not by chance, all right? There's a slightly deeper connection between properties and decorators, properties and descriptors, other than just chance. And I'm using this similarity to show you some of the main concepts about descriptors. Now, let's call it the homework for you is to, after the talk, really find out what's the connection between properties and descriptors. So let's create a very simple descriptor. This is the class person that we had before. Now, in order to create a descriptor, what I'm going to do is to actually create a new class. So descriptors are classes. They're special classes, but they are classes. So let's call it name descriptor, the descriptor that we are going to use for the name. The next thing you do is you create a class variable. Notice that name is not inside init. It's outside of init. We create a class variable name and we assign it to the descriptor. And now we need a way to tell Python how to compute the name when it's accessed. And we do that through the dunder method get. This dunder method here, this method that has a special looking name, the double underscores on the left and right of the get. It's just a regular method in the sense that it's a function, it has arguments, we can call it, it can return values, but it has this funny looking name with the double underscore on the left and on the right, because it's a magic method and quote unquote magic, in the sense that Python will call it for us behind the scenes, all right? So that's the point of dunder methods. And the dunder method get is going to be called when we try to access the value of the attribute. So therefore, if the point of this method is to return the name, then we need to return the name inside the method. So we're just going to copy this over there. So that's how it looks. Now, the interesting thing here is, and it's a very important distinction you have to make, on the left, when you're working with properties, you're going to take the first and last names from self, because you're working directly inside the person. But the descriptor is a separate object in and of itself, right? So self here points to the descriptor, okay? It doesn't point to the person. The person is actually the second argument there. The person is over there. That's why over here we see return person.first and person.last instead of self.first and self.last. So the descriptor and the object, they're related, but they're not the same object. And this is a very important distinction to make. So now let's see the dunder method get in action. This is the code we had before, except I added a small print statement just so we can see the method get being called. Now, just like before, I'm going to create a John Doe. And now I want to access john.name. So when I do that, when I type john.name, what's happening is Python is finding this class attribute right here. And when Python notices this is a descriptor, what happens is it's going to call the dunder method get. All right. And so because we are calling the dunder method get, we will see this being printed and we will get the first and the last names of John. So we see the print and then we get John Doe back. And then we can change the last name of John. That's fine, no worries. Because when we type john.name again, we go inside the dunder method get again and we receive an updated name. So the key takeaway from here is the dunder method get. It's going to run when you try to access an attribute, all right? And the dunder method get goes inside your descriptor. That's the main takeaway. So now to exercise this new knowledge you just got, let's write a slightly more general descriptor. Imagine that there's a class color that you can create by providing a hexadecimal representation of a color, okay? And in this case, FF0000, that's going to represent pure red. So we save it inside the variable red. And now I want this class to be able to have the following behavior. I want to be able to type .r to access the red component. And I also want to be able to type .g and .b to access the green and blue components respectively. So this is what I want. This is the behavior I want. How can I implement this? Well, for instance, you could start by defining your class color. You can give it an init method. And then the only thing you do inside init is you save the hexadecimal representation of the color. And then you add properties to be able to access these values and make sure they are in sync with the hexadecimal representation. So for example, we can create a property for the red component. And the thing we're going to do here is we're going to take a look at the hexadecimal representation. We're going to slice the two characters that we care about. In this case, that's going to be FF. So we slice the characters and then we use the built-in int to convert that small string into an integer. And we use the 16 over there because the string is in base 16. So that's how we can implement the red component. And for the green and for the blue, we do very similar things, but we need to update the indices on the slice. And so the thing I want you to focus on right now is that we have three properties that are very, very similar. Their only difference is the slice that you pick for each. Okay? And so what we're going to do now is we're going to replace these three properties with a single descriptor. So this is going to be an interesting exercise. See how we can do this. So the first thing we do is we create the blueprint for our code. So we start by extracting the R, G, and B into class attributes. And those will be assigned the descriptor, right? So now we can create the class that's going to represent the descriptor. In my case, I called it RGB component because we want to use this descriptor to implement RGB components of a color. And now the thing is, and this might twist your brain a little bit, but with time you'll get used to it. The thing that we want to do right now is notice that RGB component is a class. Okay, it's going to be a descriptor, fine, but it's still a class, and classes can take arguments when they're instantiated, right? We can customize classes, much like we've customized color here with the hexadecimal representation. Over here, I can customize my RGB components. What I'm going to do is I'm going to create an init method inside the descriptor, and I will use that method to save, to keep track of the start and indices of the slice. So now what I can do when I'm creating the descriptor right here is I can pass in the 1 and the 3 as arguments, because the 1 and the 3 are the numbers that we have right here inside the slice. And for the green and for the blue, I can do exactly the same thing. So now the descriptor itself will implement the common behavior here. And then these two arguments will be used to specify the slice we care about. So now one descriptor is being used for 3 attributes. The only thing that's missing is after we have this boilerplate or this skeleton, the thing we really need to turn this into a descriptor is the dunder method get. And the dunder method get, as you saw, is the method that will actually compute the value of the attribute. And so in this case, it's going to be the method that has the built-in int. It converts from base 16, and then it takes the color, it fetches the hexadecimal representation, and it slices it according to the start and end indices that we saved when we created the descriptor. I know this is a lot. You will be able to review everything when you get the slides, and then I invite you to actually type out the code and study it for a bit, add a couple of prints so you can see what's happening. Now, there's another thing I want to show you. So far, we've seen how to do dynamic attribute computations. Now I want to show you how to do dynamic attribute assignments, how to control assignments into attributes with properties and descriptors. So this is the class person from before. We have the property name that we've also seen before. And what I want to add now is a setter method. So these 3 lines right here that I just added, they give you the capability of assigning a new name to the person. So when I try to assign a new name directly, what's going to happen is I'm going to call this method with the new name here. And then what I'll do is I'll split the new name and I will update the first and the last names. So this is how you use a property to set things. So let's see how this pans out, how this works in code. So there's a print over there just so we can see when we go inside that function. So we create a person John. And then if we try to assign the name directly, like this function right here is called. And then if we try to access the first and the last attributes, you will see that they were updated because the property setter right here modified those attributes, updated them. So this is the gist of what we did. We have the class person and its setter method. So now what we want to see is how to do these dynamic attribute assignments with descriptors. How can you do this using descriptors? Again, let's see the similarities between the setter method in properties and this behavior in descriptors. Let's move the code to the side and let's start by taking the class person and again creating the class attribute with the descriptor. And then we also need, obviously, to define the descriptor. Now, what I want is to know what is the the replacement for the setter method inside the descriptor. What is it that I need to put inside the descriptor? Well, much like we had the dunder method get to get the value of an attribute, we have the dunder method set that is responsible for setting attributes. So this is the dunder method we care about right now. And again, the setter method of the descriptor is going to mirror the setter method of the property. So the functionality, the code inside the method is pretty much the same. We are going to take the new name, we are going to split it, and then we update the person.first and the person.last attributes. And again, I want you to notice that over here on the left, the property, the self refers to the person, because the method, the setter method, was defined directly inside the class person. Whereas in the descriptor set, self, notice that this method is defined inside the class name descriptor. Therefore, self refers to the descriptor object itself. That's why we need another argument that is actually the person object, whose name we're trying to change. And that's why in here we write person.first and person.last. So very important distinction to make here. The descriptor is related to the person because we created this descriptor for this class, but it's still a separate object. It's a different thing. So now let's see the dunder method set in action. And it's very similar to the property setter. We can create a John. And then when we type john.name equals something, the John here, this instance of the person, is going to be the person argument. And the new value, the value we're trying to assign into john.name, is going to be the new name here. And so the assignment itself is going to trigger this method. So we're going to call this method. That's why we got the print here, because we called this method. And after we call the method, we see that the first and last names were updated because we saved the new values here. We changed the attributes. So the main key takeaway, why do I keep saying main key takeaway? So the key takeaway from this is that the dunder method set runs when we try to assign to the attribute. That's the responsibility of the dunder method set, is to update what needs to be updated when we do an assignment. So now for another example of how to use the dunder method set, let's see how to implement read-only attributes with properties and with descriptors. Let's see how we can do that. Right, how? How can we do this? Now, this is a very, I want to say very common, but I'll just say common. It's a common pattern for properties. So properties are typically used to do this. And so we'll review that pattern, and then I'll just show you how to do it with descriptors. And I think an important disclaimer here is that the examples we've seen so far, their main focus is in showing you how descriptors work. How? Like the mechanics. They're not necessarily examples of excellent descriptors, all right? Because everything we've seen so far would be better implemented as properties, probably, right? And so I want you to focus on that. This is me showing you the mechanics and not necessarily suggesting you replace all of your properties with descriptors. All right, so now on to read-only attributes. Once more, let's take a look at our class person. I hope you're not tired of John Doe already, because we're still going to take a look at him for a couple more slides. So this is the class person here. And what I did, I don't know if you can tell already, but what I did is, instead of doing self.first and self.last, I added an underscore. And this leading underscore is a naming convention in Python. And it says that the attributes that start with a leading underscore are considered private. And I say they're considered because it's just a convention. We just want users to know, hey, you really shouldn't be messing with these two attributes because they're private, quote unquote private. You can do whatever you want, okay? It's just that it's a convention that the Python language has. And Python developers, they try to abide by these conventions. So we create these two attributes with the leading underscore. And now what we can do is create their public, now quote unquote public, their public counterparts by creating a property that's just a wrapper around the private method, sorry, around the private attribute. Notice that the property first does not have a leading underscore, and the only thing it does is return first with the underscore. So we're not actually computing anything, we're just creating a thin wrapper around the private attribute. And the idea, you'll see what the idea is very soon. So we do this for the first and for the last. And this is a fairly common pattern for properties, all right? Create a property around a private attribute, underscore first and underscore last. So now, if we have this class, if we create a John, and then if we try to change John.first, we get an attribute error. Why is that? Well, you actually already know why, because I created a property here and I did not create a setter method. And so we get an error right here. And that's how in Python, we typically try to create read-only properties, sorry, read-only attributes via properties. So can we make it better? And better here, better should also have quotes. It's for some definition of better. Again, I'm not necessarily suggesting that you should really do what I'm about to show you with descriptors. I'm just trying to show you how descriptors work and how you can implement these type of patterns with descriptors. So let's make it better by using descriptors and by learning a bit more about descriptors. So how are we going to do this? We see the same class person, but now first and last, they're assigned to a read-only attribute descriptor. So we want to create a descriptor that you can use for read-only attributes. And the idea here is that this descriptor should be very adaptable. You should be able to use it with whatever class you want, with whatever private attribute you want. That's the point. That's the challenge here. All right. So how do we do this? Because there's a key ingredient missing, and I want to show you that key ingredient. And the key ingredient here is when we go inside the dunder method get, the question we need to answer is, and it's written right here, how can the descriptor know which attribute we're accessing? How can the descriptor tell apart which attribute we're trying to fetch? And this question is solved by the dunder method setName. Now, actually, before I show you this, you should be able to implement a read-only attribute descriptor if inside the parentheses here, we gave it the corresponding name, right? So when we are creating this attribute right here, we could say inside here with quotes, we could type the name of the attribute, for example, underscore last, so that the get method knows exactly which attribute it should find. Much like with the RGB component, we specified the slice indices, right? But here, I'm trying to create a descriptor that does not need arguments. So in essence, I'm trying to create a descriptor that is aware, that knows which attribute it was assigned to. And to me, and this is one of the things I love the most about descriptors, is there is a mechanism to make this happen, okay? Descriptors can be made aware of their own not own, but of the attributes that they were assigned to. And you cannot find this anywhere else on Python. At least I haven't found it anywhere else on Python. An assignment that is aware, right? The right-hand side of the assignment knows that it is being assigned to something. This is very, very cool. And this is what I want to show you, the way through which Python tells the descriptor the attribute it was being assigned to is through the dunder method setName. So when the assignment happens, Python will try to call this dunder method to tell the descriptor, hey, you're being assigned to a specific attribute with this name. So let's see how you can create these read-only attributes with descriptors. And let's see what's the part that the dunder setName plays. What's the point of this method? So this is the code we have so far. What I want to show you is that the dunder setName is going to notify the descriptor. So notice that this method is defined inside the descriptor. This method is going to be called with two arguments. The CLS here stands for the class. It's going to be the class person, so that we have access to the whole class. And then the name of the attributes that we are assigning to. So then the point of what we should do is inside the descriptor, and again, self here is the descriptor. It's not the person, it's the descriptor. Inside self, we're going to take the name of the attribute and we're going to compute the private attribute, or the name of the private attribute that stores the actual value. Because first is supposed to be a thin wrapper around underscore first, and last is supposed to be a thin wrapper around underscore last. So that's exactly what we do here. We take the name and we put an underscore in front of it, and we save this string inside the descriptor. Inside the descriptor. Why? Because later, when we try to get the value of an attribute, we only get the object whose attribute we're trying to access. But thankfully, inside self.private attribute name, we already know what's the corresponding private attribute that actually has the value. And the only thing we need to do is use the built-in getAttr to fetch that value. And so as an example, when we do this, when we say that the class attribute first is the read-only, or is going to be assigned to the read-only attribute descriptor, the first here, this string, the first is converted into a string and it's the name argument, and the class person is going to be the class argument. And this right here, the self.private attribute name, this is going to match this assignment. So we're going to build this string and we're going to save it inside this attribute. Again, why is it this string that we care about? Because the attribute first is actually hiding the value inside underscore first. So that's the point. And so the key takeaway, the main takeaway here is that the dunder setName is what allows descriptors to be aware of their own attributes. It's the thing that connects the descriptor to the attribute of the original object. Now, that's all for today, but it's not quite everything there is to say about descriptors. All right, this was a short introduction to descriptors and to 3 important dunder methods, but descriptors are actually a lot more useful and they show up in a lot of places. So I have a couple of things to tell you about how you can exercise what you just learned and things you can look up after this talk. So like I said, I just showed you enough to get you started. Now, my suggestion is take the 3 dunder methods you just learned about and try to solve these 3 little challenges I have for you. Right, challenges. So the RGB component descriptor we created, we only gave it a dunder method get. So we were able to retrieve the value, the integer value of the components. How would you add a dunder method set to that descriptor so that you can also set the components one by one? This is an interesting challenge. Now, another thing you can do is try to add a dunder method set to the read-only attribute descriptor. And now, don't be confused, right? The read-only attribute descriptor is meant to create read-only attributes. So the dunder method set, its purpose is to actually raise an error if it runs, because we don't really want to set anything. We want it to error. And so a follow-up challenge, an interesting follow-up challenge for you to dig up how things really work and how descriptors really work is, what happens if the dunder method set is not there and you try to set the attribute? This is a very interesting question, and I would love it if you went ahead and tried to find the answer and then just reach out to me either on Twitter or through email. I'll share my email later. Reach out to me if you found out the question, sorry, the answer to this question. So what happens if you do not provide this dunder method set inside this descriptor and you try to set the attribute? And a third challenge is for you to create a descriptor all by yourself, and the only purpose of this log attribute access descriptor is to say either print or write to a log file whenever attributes are being accessed and assigned to. So that's a small descriptor you can write that will require you to use the dunder methods get, set, and setName. So these are 3 small challenges you can try to take on. And now, what's next, right? What are the next things you can look up if you want to learn more about descriptors? What's there to learn? Where should you look for more information? Well, one thing you should definitely Google or look up is the descriptor protocol, right? The descriptor protocol is the thing, is kind of the set of rules that determines when something is a descriptor. And there's 3 main ingredients inside this descriptor protocol. And actually, I only showed you 2. So there's a 3rd ingredient missing, and it's not more difficult when compared to the 2 I showed you. It's just different. So look this up and see what ingredient you're missing right now. No, sorry, my English sometimes just doesn't work. Another thing you can do is figure out what's the relationship between property, static method, and class method, and descriptors. I spent the whole talk comparing properties and descriptors. We had them side by side a bunch of times, and this was not a coincidence, all right? They are related. And actually, these 3 built-ins, they are very, very related to descriptors. There's a very tight relationship between them. And I would like to challenge you to find out what that relationship is, so that you can see that descriptors, they're not some weird metaprogramming technique that never shows up in real life. No, Python makes use of descriptors a lot. All right, you might not use them explicitly, you might not implement them explicitly very often, but they show up everywhere without you even knowing. And another place where they show up is in relation to methods and that magical argument self. So another very interesting thing for you to try to understand is what's the relationship between descriptors, methods, and the argument self. So these are just some things you can look up. Now we're really getting to a close. I just want to share a couple of references for this talk. So there's 4 links here. The first 2 links are from my own website, 2 blog articles I wrote about properties and descriptors. And the second one is actually a link from the future. So the link doesn't work right now. It's going to be working very soon. But if I were to click it right now, it wouldn't work. It's an article I am yet to publish, but it's very close to being published. And then obviously I also added a link to the descriptor how-to in the Python documentation. It's a very good document. I think it's a very good read. Now that you've heard a couple of things about descriptors, it might be a good time to take a look at this link and see if you understand what's being written there. And I also linked to another blog article by a friend of mine where they just implement property, static method, and class method with descriptors. So that's a very interesting read for you. Finally, the two articles I mentioned about properties and descriptors, they're part of my Python's book. So this is a book I wrote about writing elegant Python code, and it's a book that I make available for free on the internet because I learned Python for free in the internet. So this is my way of giving back to the community. It's my Python's book. And I would also like to say that the presentation here, this was built with Snapify. Every time I make a presentation, someone asks me what I use to build my slides. And so I just went ahead and I wanted to say this was built with Snapify so that you don't have to ask. And I'm not affiliated with them in any way. They're just awesome. The team is awesome. They're very considerate and they're working very hard on making this a very great tool. So yeah, I just thought I would thank them for allowing me to create my slides on this platform. And thank you very much for your time. I know that putting up with me might not be easy, but I appreciate your attention. This is my email address. Feel free to drop a line to say hi, to send some remarks, further questions. If you have feedback about the talk, please do write to me, and I hope to see you soon. Thank you.
Thank you very much, Rodrigo. So I think throughout this session, we delved into the fascinating world of descriptors, I would say, so, and delving the inner workings of the descriptors. So for me, it was an enlightening session. So I hope that it was for our participants too. And we explored how descriptors enabled us to define reusable behavior for our classes, fascinating elegance and flexible code designs. And also I appreciate your work on the presentation. I was very impressed because you have very put on your time over there to have this very organized. So even a person who has not joined this session can go through your presentation. That is how it has been sent. I just visited your blog, and so I was going through. So thank you very much for that. So to the participants, so if we have a question over here. So again, from the participants too, they have mentioned that it's an amazing presentation. What are the third-party libraries using descriptors? So there's a question.
So, okay, so if I understand the question correctly, you're asking me for examples about third-party libraries that use descriptors.
Yes.
All right, so assuming this is the question, I can give you one very specific example, which is Textual. So Textual is a Python framework that lets you build terminal user interfaces. So they're like GUIs, but that run inside the terminal directly. And I was working on Textual because I said in the beginning, I work for Textualize, and Textual is a framework that's being built by Textualize. And it was when I was working inside the code, so when I was trying to fix a couple of bugs and implement a couple of features, that I saw actually quite a large number of descriptors, because they're very useful when you're creating frameworks, when you want, how do I put this? So the point of frameworks is to make it easier for the programmer to do certain things. And sometimes that might require having some quote unquote magic run on the background. When the user does something, you want some extra things to happen. And Textual uses descriptors a lot for that sort of thing, you know, to make life easier for programmers. When they set some attributes, we use descriptors to then run a couple of other related things on the background, for example. And I'm sure there are many other third-party libraries that use descriptors. The thing is, because I do not know their source code, I cannot name them. I'm sorry. It's just I don't know which ones. But you can try and go look them up for yourself. I'm sure you'll find some.
Okay, thank you, Rodrigo. And if there's any other question, you guys, everyone, you can use the question and answer tab. So if there's any questions. So before we wrap up, we have another 10 to 15 minutes. We'll give another minute for the people. Also, in between, I have to mention that I just visited your page, manspp.com. So, and it says like take your Python skills to the next level, and definitely I will be connecting with you on this. So because I want to take it.
Okay, that's
I'll
very
be
nice.
definitely connecting with you. Yeah.
All right, thank you very much. Thanks. I appreciate your kind words.
Yeah. If everyone is good, yeah, we can wrap up. So in closing, so I hope that the insight gains from this session will empower you to harness the full potential of descriptions in your Python code. And also may you continue to explore and master in the fascinating aspect of the language, because, you know, learning never stops and we have to continue to learn. So paving the way to the innovative and elegant solutions. So thank you very much, especially again, Rodrigo. So your presentation is like awesome. So I will say like, we can see that the time that you have spent on your presentation. So that was very nice. And thank you for your participation, guys. So we value your time and hope to see you in the upcoming sessions as well. So I'll also, Rodrigo, thank you again, and we will hope to have you in our upcoming conferences as well. So thank you very much.
Thank you very much. Have a good conference.
Thank you. Bye.